Okay, today we're going to talk about end behavior of polynomials. And when we're talking about end behavior, we want to know what's going to go on a graph when we try to graph these things at either the very beginning or the very end. Because remember, just like any other line, we're going to put arrowheads on these so they go forever. So what happens at the two extremes? Okay, so let's start with this one. This is just a simple line. It's y equals mx plus b. And notice that there's a hidden power here, and it's the power of 1. So this is an odd power. And odd powers are going to be just like your lines. They start low and they end high. Okay? So anytime you have an odd power as your leading exponent, here are our leading exponents right there, it's going to go from low to high as we go left to right across the graph. Okay? Next one I want to look at is this one, y equals x squared. Okay, this is a parabola shaped like this. That's your standard parabola. And in this case, we start high and end high. So an even power is going to start high and end high. Okay, so these are shaped like U's or W's or things like that, but it's going to start high and end high. Okay, anytime you have an even power, that's also true. So let's look at y equals x to the third. In this case, we have an odd power. So it's going to start low and high, but it has a little wiggle in the middle. And that is what y equals x to the third looks like. And you can keep doing this game. If you got y equals x to the fourth, it's going to start high, have a couple wiggles, and end high. Okay, and as these powers go up, you just add more wiggles in the middle. So maybe by the time we get to the fifth power, it would look like this. Okay, there's just some extra wiggles in there. And that's all, but it's always going to start high, end high. If it's an odd power, it's going to start low, end high. Now, there is a few exceptions to these, and the biggest exception is going to be a leading negative sign. So here, these were always positive, in this case, positive 1. But if they're negative, so let's look at y equals negative x squared. As a matter of fact, I'm going to write these in red so you can see the difference. So let's look at y equals negative x squared. And instead of being the u, it's just a rainbow. It's flipped upside down. So in this case, when it's a power, normally it would be starts high, ends high. With the negative sign, it's a reflection of that, so it means it starts low and ends low. So if we had graphed y equals negative x to the fourth power, it would look just like this, but flipped upside down. That's one too many bumps, but you got the basic idea. Okay, it's going to start low and end low. Okay, same thing with our cube. You put a negative sign out front of it, it will start high and low. So if we had y is equal to negative x cubed, starts high, wiggles, and ends low. Okay, so generally speaking, if it's an odd power, it's going to start low and end high, unless this leading coefficient is negative, in which case it's going to be reverse of that. It's going to start high and end low. And anytime it's an odd power, or an even power, excuse me, like y equals x squared, anytime it's an even power, we're going to start high and end high, unless the leading coefficient is negative, and then it's going to be an upside down, and it's going to be starts low and ends low. And then as the powers go up, all that happens is you get extra wiggles in the middle. So this is end behavior. If you have any questions, please make sure you ask.